Okay, welcome back. Topic 2.5. Now we're going to talk about formal charges. Formal charge is where we start looking at the charges of the individual atoms inside of the Lewis structure. Okay. You can have a formal charge on any type of Lewis dot structure, but we're usually more concerned about formal charges when we're looking at the charge of ions. Let's take a look at the nitrate and the sulfate ion. We can all see that nitrate total has a -1 charge, and that sulfate total has a -2 charge. But what is actually causing those charges? To understand that, we look at the formal charge, and to look at the formal charge, we need to look at the individual atoms inside of the actual Lewis dot structure. Let's start with nitrogen. If we want to determine nitrogen's formal charge, we need to look at the valence electrons that nitrogen has in its immediate vicinity. Okay? Not the total amount of electrons that nitrogen is sharing with the other atoms, we just want the immediate vicinity. And the immediate vicinity can be determined if we draw a circle around the valence electrons that are right next to nitrogen. Okay? You can see that's separate from these valence electrons out here, because those valence electrons belong to the oxygens, but the ones closest to nitrogen belong to nitrogen, and those are the electrons in the immediate vicinity. As you can see, the valence electrons in the immediate vicinity, there are 4 of them. There's one here, one here, one here, and one here. So 4 valence electrons in its immediate vicinity. Normally, nitrogen has 5 valence electrons under normal conditions. If you look at your periodic table, you will see that nitrogen has 5 valence electrons, but in this Lewis dot structure, it only has 4 around it. So to determine the formal charge of the nitrogen, we take the usual amount. I totally misspelled that. Of valence electrons, and then we subtract it from the valence electrons it actually has. Alright? And in the case of nitrogen here, we already know that it has 5 valence electrons normally. Right now it only has 4 available, and 5 minus 4 is a +1. Okay? So there is a +1 formal charge on the nitrogen. There's a +1 formal charge on the nitrogen. I'm going to go ahead and rewrite this Lewis dot structure so that that circle is gone. With the +1 charge on it. Now let's look at the 2 oxygens, okay? The 2 oxygens. Or the 3, I should say. So this is for nitrogen. And then we'll do these 2 right here. So let's circle the electrons in their immediate vicinity. And because those are both the same, we'll do them onto one calculation. Normally, oxygen has 6 valence electrons. But in this case, for both of these oxygens, there are 1, 2, 3, 4, 5, 6, 7. And the same thing for this one. 1, 2, 3, 4, 5, 6, 7. 6 minus 7, ladies and gents, is -1. So each one of those oxygens there has a formal charge of -1. So we'll put -1 signs on both of those. And then I'll just show the work down here for the other one as well, because we're actually going to need it. Okay, then for the other oxygen, which is up here, circle the valence electrons in its immediate vicinity. Normally it has 6. Subtract it from how many are right there. We have 1, 2, 3, 4, 5, 6. Okay, so this one has no formal charge. And so therefore we don't need to put anything on it. Now you guys can start to see where the total charge of the ion comes from. Because if we add up all of the formal charges of the individual atoms inside of the Lewis dot structure, we should get the total charge of the entire molecule. And in this case, +1 plus -1 plus -1 is equal to -1, and then that's where that comes from. So from now on, it is very, very important that if you have an ion, it's always a good idea to show the formal charge on it, especially if the question asks for it. Okay, let's go ahead and do the same thing for sulfate. Let's determine how the -2 charge comes from sulfate. We'll start with the sulfur. And if you look at your periodic table, you should be able to determine that sulfur usually has 6 valence electrons. We'll subtract that from the electrons that it has in its immediate vicinity. And there are 1, 2, 3, 4. 6 minus 4 is +2. So there is a +2 charge on that sulfur there. Each of the oxygens are the same. And we all know that oxygen usually has 6, but each one of these oxygens has 1, 2, 3, 4, 5, 6, 7. So let me show you that. 1, 2, 3, 4, 5, 6, 7. So that's -7, so that's a -1 charge. But there are 4 of them that are like that. Okay, so we're going to put a -1 on each one of these oxygens here. And if we add up all of those charges, the 4 -1s and the +2, we will end up with a -2 charge, and then that's where that comes from. Okay, so go ahead and work through the example problems, and be sure to write the formal charges next to the atoms that they represent, and make sure you are very, very clearly showing which atoms have the formal charge on it. So for instance, and this happens every year, if you put this +1 a little bit too far up here, I'm going to think that you're putting it with oxygen and not with nitrogen. So it's always a good idea to put it as close to the atom that it belongs to as possible. Alright, we'll see you in the next video.